video lecture series on digital electronics. In the previous video lecture, we discussed about various types of number systems. In this video, we discuss about the number conversions, that is, how to convert one number into other number systems. This is also called base conversion. Since we learned four different type of number systems, it is possible to convert one number into other three number systems, producing total there are 12 different type of number conversions. All these 12 different type of number conversions are categorized into the following five different type of number conversions. So in the first category, we will discuss how to convert the decimal number into other base. That is, the decimal number is converted into binary, octal and hexadecimal number systems. In the second type of category, we will convert other base numbers into decimal. That is, the binary, octal and hexadecimal numbers are converted into decimal. In the third category, we will discuss how to convert a binary number into octal and hexadecimal number systems, and the vice versa. That is, the conversion of octal and hexadecimal numbers into binary. In the fourth category, in the fourth and fifth category, we will discuss how to convert the octal numbers into hexadecimal and vice versa. That is, the hexadecimal numbers into octal. In this case, the direct conversion is not possible. First, the given octal or hexadecimal number is converted into binary, and then this binary number is converted into either a hexadecimal or octal number. This is an indirect conversion. In this video, we will discuss about first two categories of conversion, that is, a decimal number into other base and other base numbers into decimal. So, to convert a decimal number into other base, if the decimal number contains both integer part and fractional part, then convert both parts of the decimal number into other base individually. That is, it uses two procedures to convert the integer part of the decimal number into other base and the fractional part of the decimal number into other base. Total, there are two procedures are involved. To convert to convert a decimal number, that is the integer part, into other base, divide the number by the base and collect reminders in reverse order. So for example, if you want to convert a decimal number, only the integer part of the decimal number into other base, simply divide the decimal number by the base to which it want to be converted and gather the reminders. So the division is continued until the quotient becomes 0. In the second part, if you want to convert your decimal fraction into other base, simply multiply the decimal fraction by the base and collect the integer part of the result as a carry, and the multiplication is continued until the fraction becomes 0. So these two procedures are explained with the help of an example in the next slide. Let us consider an example of converting a decimal number into binary, that is the other base, or conversion of a decimal number into base 2 number system. Right? So the following two types of operations are takes place while converting a decimal number into its equivalent binary number. So in the first case, division of an integer part and successive quotients by 2. This is the procedure to convert the decimal number or the integer number into base 2. In the second step, multiplication of fractional part and successive fractions by base 2. So the second step is used to convert the decimal fraction into binary number system. So in this example, we consider a decimal number 58.25 into binary. So here the 58 is an integer part and 0.25 is a fractional part. So two procedures are followed. In the first step, division of 58 and successive quotient by 2. In the second step, multiplication of 0.25, that is the decimal fraction, and its successive fractions with base 2. So let us see how do we convert. So in the operation column, I need to divide the integer part of the decimal number, that is 58 by 2. So 58 by 2, the quotient is the 29 and the remainder is 0. And this division is continued, that is 29 by 2. In this case, the quotient is 14 and the remainder is 1. Again, the quotient, that is 14, is division by 2. So in this case, my quotient is 7 and the remainder is 0. And this division is continued, that is 7 by 2. In this case, the quotient is 3 and the remainder is 1. Again, 3 by 2. So the quotient is 1 and the remainder is 1. And again, 1 by 2, this is not possible. So a number is divisible if it is greater than or equal to the divisor. So in this case, 1 is less than 2, so the division is not taking place. The remainder is as it is the quotient, that is 1. So as we collected all the remainders, so the remainder should be written in a reverse manner like this. So that is, the 58 is the decimal number, its equivalent binary is 111,010 of base 2. So now we will convert the decimal fraction, that is 0.25, into its equivalent binary by multiplying it 2. So if we multiply 0.25 by 2, it gives you 0.50. So in the result 0.50, the integer part, that is 0, is considered as a carry, and the fraction is further multiplied by 2, that is 0.50 is multiplied by 2. In this case, the result is 1.0. So the integer part is 1, that is collected as a carry, and the fraction, that is 0.0, is multiplied by 2, that gives you 0. So we will stop the division over here. So the 0.25, in this case, the carries are collected in normal order from top to bottom, whereas in the first step, the carries are collected in reverse order, that is bottom to top. So now coming to the second step, the fraction value 0.25 is equal to 0.01 of base 2. So this is how we do convert the fractional part and the integer part separately. At the end, we combine both the results to get the decimal equivalent of the given number, that is 58.25 is equal to 111,010. This is my binary equivalent of 58.01. This is my binary equivalent of 0.25. So this is how we will convert the given decimal number into its equivalent binary. So now let us see how to convert a decimal number with both integer part as well as fractional part into octal number. So same case, in the binary number system, the conversion involves two different type of operations. The first one is the division of the integer part by the base. In this case, the base is 8 because I want to convert my decimal number into octal. So the base of the octal number system is 8. So the integer part of the decimal number is divided by 8, whereas the fractional part of the decimal number is multiplied by the base 8. So let us consider an example, that is 58.25 is a decimal number and I want to convert this number into its equivalent octal number. So again, the number is a combination of both integer as well as fractional parts. So the integer part is converted separately by doing division, whereas the fractional part is converted into octal separately by multiplying with 8. So let us see how to convert this. So first, the integer part, that is my 58, it is divisible by base, that is 8. So 58 by 8, the quotient is 7 and the remainder is 2. Further, this quotient to be divided, so that is 7 by 8. So this is not possible. So there is no quotient and the previous quotient is treated as the remainder, that is 7. And we collect the remainders from reverse order, that is bottom to up. So my 58 base 10 is equal to my 72 of base 8. In the second step, we will convert the fractional value, that is 0.25 into its octal equivalent by multiplying it 8. So if you multiply 0.25 with 8, it gives you 2.0. So in the result 2.0, the carry is 2 because the integer part is collected as a carry and the fractional value further goes for the further multiplication, that is 0.0 with 8. So it becomes 0, so we will stop the multiplication over here and we will collect the remainder from from top to bottom. So that is my 0.25 base 10 is equal to my 0.2 base 8. So at the end, we will combine both the results from step 1 and step 2 to obtain the octal equivalent of given decimal number. So here the given decimal number is 58.25. Its octal equivalent is 72.2 base 8. So now let us see how to convert a decimal number into hexadecimal. So that is a decimal number into base 16 number system. So again, the decimal number I want to convert into base 16. So the conversion involves two types of operations, that is division by 16 and multiplication by 16. So the division takes place for the integer part of the decimal number and the multiplication takes place for the fractional value of the decimal number, right? So if you want to convert your decimal number into hexadecimal, simply do division with 16 if it is an integer part. If it is an fractional value, multiply by 16. Again, consider the example 58.25 is the decimal number. It has an integer part 58, so it is divided by 16, and it has a fractional part 0.25, it is multiplied by 16. So let us see the first step, that is division. So here the integer part is 58, it is divided by 16. In this case, my quotient is 3 and my remainder is 10. So further this quotient is go for division, that is 3 divided by 16. It is not possible. So my previous quotient is treated as the remainder. And while writing the remainders, we will collect from bottom to top. That is my 58 equal to 3. So here instead of 10 we need to write a, because in hexadecimal number system there is no digit 10. So instead of 10 we use a. So if we collect the remainders, that is 3 and a base 16. In a similar manner, to convert my fractional value, that is 0.25, it is multiplied with 16. So if I multiply this one, my result is 4.0. So here the integer value is 4, that is considered as my carry, and the fractional value further go for the multiplication, that is 0.0 into 16. In this case the result becomes 0, so we will stop the multiplication and we will gather all the carries from top to bottom. So that is my 0.25 base 10 is equal to my 0.4 base 16. At the end, we will combine both the results from step 1 and step 2 to obtain the hexadecimal equivalent of given decimal number. That is 58.25 base 10 is equal to 3a.4 base 16. So this is how we will convert the given decimal number into rest of the three number systems like binary, octal and hexadecimal. Simply do the division and multiplication with the base. Now we will discuss the second category of number conversion, that is the conversion of other base numbers into decimal. So here the other bases refers to binary, octal and hexadecimal. So in this procedure, in this category, we will discuss how to convert your binary or octal or hexadecimal numbers into decimal numbers. So it's a three-step procedure. In the step 1, determine the positional value of each digit. So in a given number, first we need to identify the positional value of each digit. In second step, multiply the obtained positional value, that is nothing but the column value, by the digit corresponds to each column. So in the first step, we need to identify the positional value of each digit. In the second step, the positional value of each digit is multiplied with its corresponding digit. At the third step, whatever the multiplication we done in the second step, all these product terms are get added. Sum the products calculated in step 2. So the total is the equivalent value in decimal. Right? So this is how we will proceed to convert other base numbers into decimal. It's a very simple three-step procedure. Identify the positional value, multiply the positional value of each digit with its digit, and at the end add all the results or add all the product terms. So let us see with an example. So in the example, we will convert a binary number into decimal, a octal number into decimal, and an hexadecimal number into decimal. There are three examples we are going to study. So in the first example, let us see how to convert a binary number into its equivalent, decimal equivalent. So if you observe, the given binary number contains only the integer part. There is no fractional parts, right? So first to write down the number as it is and find the positional value of each digit. Since it is a binary number whose base is 2, so the positional value varies in the power of 2. That is, the positional value of the 1 is 2 power 0, 0 is 2 power 1, and 2 square, 2 cube, and 2 power 4. This is what my first step. Identify the positional value of each digit. So in my second step, multiply each digit by its positional value. So that is nothing but I have to multiply my each digit with its positional value, that is 1 into 2 power 4 plus 1 into 2 cube plus 1 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0. So we need to multiply, that is 2 power 4 is nothing but 16, 16 into 1 that is 16 plus 2 cube is 8 plus 2 square is 4 plus 0 into anything is 0 plus 1 into 2 power 0 is 1, so 1. At the end, third step, I need to add all these things. So if I add all these things, it gives you my 29. This is my decimal equivalent of the given binary number. So the decimal equivalent of the given binary number 11101 is 29 of base 10. So this is how we will convert if the binary number contains only the integer part, there is no fractional part. In the second example, we will see how to convert a binary number into its equivalent decimal if the binary number contains the fractions as well. So in the example 2, a binary number is given. It contains the fractional value as well. So as we will know the steps, the first step is to identify the positional value. So in this case, the positional values are identified starting from the decimal point. So that is, the positional value of 1 is 2 power 0. The positional value of 0, the positional value of 1 is 2 power 0. The positional value of 0 is 2 power 1. The positional value of, again, next one is 2 square, 2 cube, and 2 power 4. Now coming to the fractional value, the positional value is in the order of 2 power minus k. That is nothing but where k value is 1, 1, 2, and so on. So for the positional value of 0, after the decimal point is 2 power minus 1, 2 power minus 2, and 2 power minus 3. So in the next step, we need to multiply all these digits by its positional values. So that is, multiplying 1 into 2 power 4, that is 1 into 2 power 4 plus 1 into 2 cube plus 1 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0, 1 into 2 power 0, plus the fractional values is also added, that is 0 into 2 power minus 1 plus 1 into 2 power minus 2 plus 1 into 2 power minus 3. So now we will multiply and add it. So if you multiply each one, so that is 1 into 2 power 4, 2 power 4 is nothing but 16. So 16 into 1, that is 16, plus 1 into 2 cube, that is 8, plus 1 into 2 square, that is 4, plus 0 into 2 power 1, that is 0, plus 1 into 2 power 0, that is 1, plus 0 into 2 power minus 1, that is 0, plus 1 into 2 power minus 2. 2 power minus 2 is nothing but 1 by 2 square, that is nothing but 1 by 4. So 1 into 1 by 4 gives you 0.25. So in the similar manner, 1 into 2 power minus 3 is equal to 0.125. So if I add all these things, it is equal to 29.375 of base 10. So this is how you will convert if the binary number includes the fractions as well. So at the end, the decimal equivalent of the given binary number is equal to 29.375 base 10. So in the third example, a octal number is given, that is 237.34, and been asked to convert into decimal. So as usual, first we need to identify the positional value of each digit. So in this case, the positional values varies in the power of 8, that is 8 power 0, 8 power 1, 8 square. So for the fractional value, it is 8 power minus 1 and 8 power minus 2. So now in the second step, we need to multiply each digit by its positional value, that is 2 into 8 square plus 3 into 8 power 1 plus 7 into 8 power 0 plus 3 into 8 power minus 1 plus 4 into 8 power minus 2. So if we multiply these things, so this is equal to 2 into 8 square. 8 square is nothing but 8 into 8, that is 64. 2 into 64, that is 128, plus 8 into 3, 24, plus 8 power 0 is 1, 1 into 7, 7, plus 8 power minus 1 is nothing but 1 by 8. So 3 into 1 by 8, that is equal to 0.375 plus, so this is equal to 4 by 4 into 8 square, that is nothing but 4 by 64, that is equal to 0.0625. So in the third step, I need to add all these product terms. At the end, the final result it gives you is 59.4375 base 10. So this is the given decimal equivalent of the given octal number, that is 159.4375 base 10. So in the fourth example, a hexadecimal number is given, that is 2AC.FE, and been asked to convert into decimal. So as usual, we will first find the uh, positional values. In this case, the positional values varies in terms of the positional values varies with 16 power 0, that is 16 power 0, 16 power 1, and 16 square. For the fraction, it is 16 power minus 1 and 16 power minus 2. Next, we multiply, that is 2 into 16 square plus, in this case, it is a into 16 power 1 plus c into 16 power 0 plus f into 16 power minus 1 plus e into 16 power minus 2. So if you observe, while multiplying, you cannot multiply a alphabet with a digit, that is a into 16 power 1 and c into 16 power 0. But in hexadecimal number system, a represents 10. So each alphabet is replaced by its equivalent value, that is 2 into 16 square plus, instead of a I can write 10 into 16 power 1 plus, for c it is 12 into 16 power 0 plus, for f it is 15 into 16 power minus 1 plus, for e it is 14 into 16 power minus 2. So now I will go for the multiplication. It gives my 2 into 16 square is 512 plus 10 into 16, that is 160 plus 12 into 16 power 0, that is 12 plus 15 into 16 power minus 1, that is nothing but 15 by 16, that gives you my 0.9375 plus 14 into 16 power minus 2, that is 14 by 16 square, that is equal to my 0.0546. So if I add all these things, at the end it gives you my 684.992 base 10. So this is what the decimal equivalent of my given hexadecimal number. So in this way, you can convert any decimal number into other base by multiplying and division by the base, and any number can be converted into decimal by identifying positional value and multiplying and adding it. So you can practice these examples. So in the first example, convert the following decimal numbers into other three number systems. So in the first example, we given three decimal numbers and been asked to convert these decimal numbers into binary, octal, and hexadecimal. So for the conversion of each digit, that is A, B, C, all these three bits involves both the procedures, that is division and multiplication. And in the second example, convert the following numbers into decimal. So there are various number systems are given other than decimal and been asked to convert it into decimal. So in this case, you need to identify the positional value of each digit and multiply it and add it. And the third example is quite different. So a decimal number is given at 24.37 and been asked to convert into base 4 number system, right? So whatever the base it is a base 4 number system or a base 2 number system or a base 8 number system. So in the Conversion procedure, we said decimal to other base. So other base can be anything, not only 2, 8, 16. Other base can be anything. So in this case, the integer part, that is 24, so which is divided by 4 and proceeded, and the fractional value 0.32, that is multiplied by 4, because you want to convert your decimal number into base 4 number system. So divide by the base and multiply by the base. So like this, you can practice these examples. So that's all for today. Thank you.